here we are more focused on how do we make these model inference available easily to the application or to the users, right? I mean, because the setting up and then running the model locally is a right nightmare, right? So we are trying to simplify this process and trying to uh, give this model inference as a service, as a kind of a remote service where devices or any other service can connect and do the inference or the speech recognition text transcription over the internet or over the network. So it is in two modes. So one is batch mode. In batch mode we give the whole file as one request, and we get the text of the whole file after some time. So there is a lag. So we let's say we submit a 10-second or 15-second request, we'll get the text after this whole file is processed, right? The other mode is streaming mode, where people are speaking on the mic, and as they are speaking, the words are getting transcribed, and they are visible to the user on the screen. So it is real time. On batch mode, we have two types of audios. Like one is very short audios, which is around less than 1 minute, and the long video, which are it can be large audios like 10 minutes, 30 minutes. So how do we tackle that? So we'll discuss about that. Yeah, for the batch mode, basically less than 1 minute, we do the model and give the transcription. For batch mode, which is greater than 1 minute, that is where we use the WAD. You remember the WAD that we use in our pipeline?
Yes.
Hello?
Yes,
Yeah.
yes, yes.
So same utility we use here for inference. So let's say you submit an audio of 10 minutes. Okay. So it will go through the WAD first. It will try to split that into multiple chunks of 15 seconds around, and then it will go to the model, and model will do the inference on them, and then it will combine the text of the output of that model, and it will give in the response of the service. That is how we are tackling this, because this inference has a limitation. It cannot work well on the utterances which are greater than 1 minute. So we have to break them up for the inference. So breaking has its own challenges. I think if you want to go deeper down, maybe Anirudh can discuss more. So basically,
So Rajat, I have a question on that. So batch mode means it is offline.
no.
Speech
Batch
recognition or
batch
streaming
mode
means
here,
online,
I
is it?
think, no. So batch mode here means uh, complete file. So I'll show you. I'll show you what it means. It's not offline. It's something else. Okay. So streaming mode, as I said, and the streaming mode from the mic, as you get the voice, there is a frame basically, and if the frame is having the voice, we collect the voice and do the chunking and give to the model. And if there is no voice, then basically it recollects and give the complete request to the backend basically. So for this workshop, I am not touching the hands-on experience on the streaming mode, because we are still trying to build a documentation and making it more usable right now. So we will publish the SDK for it. SDK means software development kit. It will be easier for anyone to integrate. They can basically easily plug in that code into their maybe mobile application or UI or web application quite easily. So we are in the process of that, but for today's workshop, I think let's limit to ourselves to the batch mode only. I'll show you how the streaming mode looks like anyways. So just a quick demo I would like to give to everyone so that they understand what I mean and basically connect to. Yeah, this one is already there. So this is our portal. This is just for demo purpose. We have kept it. It's not used in anywhere in any application right now. It's just for demo purpose. So here you can choose multiple models from here. Like let's say I want to try out English model. I'll go with the English model. And this is the mic. And this is where the streaming mode is basically. As you speak, you will get the text in the output. So if I speak, right now we are in a workshop and we are discussing about the model inference API. Okay, I think, did you get that? So how it worked? I mean, it started, it actually did something wrong. It said discussed, right? Then it corrected itself because we are continuously sending the chunks to the API and it is continuously doing the cumulative, cumulative inference. And at some point, we are breaking that cumulation as well. We are breaking that using the WED again at the backend. So this is how it is working, and it is also adding the punctuation at the end, if you see here, right? So this is the streaming. This is streaming that we are calling. What is batch mode? So batch mode is this one. So you have the whole file, complete file, and you basically send it as a request. Let me see if I can. Yeah. So if I upload this file, I can hear that as well. Oh, this is not English, basically. Let me find it. Anyways, let me run it. Let's see how it runs. It would be weird, some weird on English. It is not English audio too. So let's see how it works. Okay. So here we got the SRT file. So SRT file basically is a very, yeah, I think you all might be aware of it. So SRT file gives you the timestamps and all the other information for the text. Let me just quickly use text. It would be very weird because I used some other language, but it still tried in the Ashram Dhanusha. So from 0 to 7 seconds, it is having 20 words, and this is the first utterance. Since it is a small file, it is basically just doing the only in one chunk. If it is like, let's say 10 minutes file, then it would break it into multiple chunks, basically. So this is this batch inference work, and this is the model. I mean, this is our portal where it is just for demo purpose. The real thing is the API that we have built, which basically allow you to provision in your own infrastructure. You can run it in IIT Dharwad infra, or you can run it in IIT Guwahati, or next step we run it in next step infra. So that way we have built it like you can run it anywhere in any cloud. Let me just see. Yeah. So I think it is. Is it clear basically to?
Yeah, it is clear, but I have some doubt on the streaming mode. You are telling you are only taking voiced frames or voiced chunks you are taking. I'm not so sure on that. Because at the time of training you have taken for that web to web model, you are not considering voiced frames only, no? All the whole web files you are giving. So
Yes.
now, what is the meaning of taking this voiced frames? Frames means it is again 25 with some shift or 25 millisecond with some shift, or you are telling frame means something else, means some duration. I'm not so
Yeah,
sure. Can
yeah.
you
So
elaborate on
yeah. So what's happening is so suppose the problem is that if you open a mic stream, right, and you basically keep on speaking, then it can go till, I mean, the duration is not fixed, right? So the model limitation is that it can handle audio only till 1 minute because of the model size and the GPU size. Okay, so if you give an audio which is greater than 1 minute, it is not able to transcribe because of memory error. Okay, so how to go about this is we have to cut the audio, right? And how do we cut the audio? If we cut the audio randomly, then we can basically mess up the edge words, so
that?
they
Correct.
can get, yeah. So when you are opening a mic stream, the duration is not fixed, right? And everything is going to the model. Everything is going to the model, whatever chunks are getting. So instead of sending everything and basically just invoking the model when the voice chunks are present, we are basically
So are you detecting start point and end point with respect to duration?
No, no, no.
Generally, if we see that Amazon Alexa and all this, they have some startup word kind of thing, no?
No, no, no.
Walk up word.
Yeah,
So
we don't have a wake
you
up
don't
word.
have that
We
kind,
don't have a
correct?
wake up word. So
So
whatever
voice
stream is there.
frames, starting voice frame you are taking, but maybe there may exist in between some voice units. There may have some silence units, no?
Right.
So that you are also removing, or you are considering that?
So that is a tunable parameter, right? So that is how much silence you at what amount of silence you want to basically refresh the stream. Okay, so that is a parameter which we can adjust. So currently we have kept it as something, but on silence it basically refreshes the stream. Okay, so that is what is happening.
Okay.
Did I? If it's not clear, maybe I can explain more.
Not the streaming mode is not, maybe you are got the start point. Suppose whenever the you are passing through a voice activity detector, maybe it is a classifier in your case. So maybe you got the start point where this voice frame starts, correct? So then after that, maybe there exists, suppose I am talking now, I have pause in between, correct? So then I am going for the next word. So are you also giving that pause to the system, or you are removing that? Only first part you are taking, then next you are whatever you are taking, then concatenating on that.
So how the voice activity detection is working? It is working at the frame level. Okay, it is not finding the starting point or the starting duration of the voice activity. At every frame, it is specifying whether it is a voice chunk or not. It is a frame level classification.
So frame duration, can you only tell me what is the frame duration you are considering?
Yeah, frame duration is 20 milliseconds.
20 milliseconds. Okay.
Yes. So each frame we are specifying whether that frame has voice or not, right? And if it has a voice, we keep collecting it as voice chunks. Okay. We keep collecting it, and there's a model which is continuously running on that chunks. Okay. And when we find a silence, we basically say that, okay, we don't need to accumulate more. Let's refresh this chunk, and then new voice chunks will start accumulating once we start finding it.
So you were telling that continuous voice chunks, wherever there have continuous voice chunks, you are considering that. Whenever there will be abrupt change of that, then you stopping that, maybe from the next chunk you are taking that, is it?
Yes. So whenever there is an abrupt change means when the VAT says that it doesn't have voice, right?
Okay.
So that can be silence. And all these things are very dependent on there's a bottleneck about the quality of voice activity detection also, right?
Correct.
I mean, so this is also not a completely solved problem, because we have seen that even the slightest of noises like a bird sound. So a bird sound confuses a VAT very much. So even if someone is speaking and there's a bird in the background chirping, the VAT is usually not able to detect whether it's a silence or not, even though the person has stopped. So that is a bottleneck of this method. But yeah, at least it basically preserves the accuracy, because we are not splitting abruptly. So
okay, so you are that means even you are getting one unvoiced frame. So you are means cut the chunk there, or you are seeing some 4 or 5 continuous unvoiced frames, then you are chunking from that.
No. So every frame is getting going into the VAT. Every frame. So that is how. Yeah.
No,
So
I got it. Every frame is going into VAT, and the VAT output, maybe it should come like 110 111, then 0 0 0 0 0 1 1 1 1 1. Then how that chunking you are giving means
right.
chunk you are giving to that web to vec model, no? That CNN input, correct?
Right. So that is the logic of accumulation. So at what point we are basically cutting refreshing the voice chunks,
Correct. That I
and
am asking,
for that we have a threshold of silence. Okay. So if let's say we have 4 zeros in a row, we say that, okay, let's give it to the model and refresh this chunk. We don't want to basically continue.
Means there have, if there have continuous unvoiced frames, then you are jumping.
Yes, and that is a tunable parameter that someone can use.
Okay. Thank you.
Hello, sir.
Hello. Yeah.
Yes, sir. How are you able to manage load all the systems in one particular framework?
Yeah. Rajat may be able to answer that.
Yeah. So
Okay.
what we are doing is basically we are going to deploy this on the Kubernetes.
Okay.
In the Kubernetes, for every model, there would be a one pod running.
Every model will be one
Pod,
thread.
one
Okay.
pod.
Okay. Pod. Okay.
Right.
Pod.
So if
Yeah.
let's say I have 10 models, there would be 10 pods running. And those 10 pods we can independently scale as well. So let's say for Hindi, I want 3 pods. So I can run 3 pods for
Okay.
Hindi. And let's say for English, I just want 2 pods. So I can run 2 pods for English. So that way you can independently scale based on the language as well. So that is our
Okay.
architecture, which is going to come very soon. We are already working on this. So right now we have developed whatever we have open source. It runs only on a single machine, so you can load multiple modules in one only. But yeah, I mean, if you want to scale, you have to run on Kubernetes cluster. That's it.
Okay. Then, I mean, what about the load balancing? I mean, there'll be multiple hits, right, simultaneously.
Yeah, everything. Yes, so everything will be handled in that whole architecture that we are building.
Like,
Load
can you
balancing API
specify the
gateway.
architecture if possible?
I'll have to find that.
I mean, is it something like master slave or some other thing?
So the architecture would be basically as the pods will be running as a service, right?
Okay.
All the pods, and there would be a load balancer on top of that on every
Okay.
family, on every group of pods. Let's say English it is, so there will be one load balancer for English. If it is Hindi, there would be one load balancer for Hindi, and then on top of that, at top topmost layer, it would be API gateway. So based on the language, it will redirect the request to your load balancer, and then load balancer will do the round robin
Okay.
routing
Yeah.
operators.
Yeah. Okay. Understood. So it's like similar to like master slave architecture.
Yeah,
I mean,
yeah,
there
it is
there, there
master
will
slave.
be
I
a there
mean,
will
there can be multiple load balancer as well. So that's why I don't want to call it master slave, but yeah, it is
okay.
like that.
Okay. Okay. Yeah. Thank you.
Okay. So yeah, so the architecture right now, which is right now what I am presenting is not scalable, but we are already having that scalable architecture which is running in our infra, but the documentation and it's not there for usage for public. So we have not, I'm not touching that, but we are already working on that Kubernetes architecture. So this is the architecture right now, which is very basic architecture. And so we are using gRPC. So gRPC is basically it's for remote processor call. So gRPC server runs, and on top of that, you can have multiple types of clients. You can have Python client, you can have Java client, or you can have .NET client like C# client, or uh, it can be other types of language support like Golang and other things. So you can write your server in one language, any one language that you choose. So we have written in Python, and you can basically create multiple stubs on for different languages. So that way it's very easy to integrate in like multiple devices like iOS. If I want to integrate, or Android, I can just give that gRPC and publish it in the public, maybe as a SDK, and the people can basically use it. So that is how is the architecture. On the left hand side, it is nothing but a layer on top of this, which is API gateway. It actually translates your JSON to protobuf. So gRPC is nothing but it is a remote processor call which communicates over the binary protocol. Basically, it's a binary protocol. So, but REST understands JSON, right? So, if you want to communicate over the REST, then there is a layer in between which converts your JSON requests to protobuf requests. So, yeah, that is a basic architecture. So, if I want to go to the these are the prerequisites. So I think all these prerequisites you already have: Docker, Conda, Python, Git. gRPC I will discuss in the hands-on sessions. So gRPC is it's a kind of a remote processor call, right? So when you what it means is when you write a code, you call a function, right? You call a method. If that method is running over the network in some other remote location, it becomes a remote processor call, correct? So it simply basically is nothing but kind of a remote call to some other service which is running, and it is seamless on the client side. It is seamless for the user. It looks like it is calling a local method, but it is fundamentally it is going over the wire to some other remote service. So it gives that framework, and the reason we chose this is basically it is very lightweight, because this audio thing we are processing, and it's very resource hungry. So we wanted to keep the messaging layer very lean. So this supports protobuf, which is very it takes very less space, and it is very performant. So it gives you that capability of doing the very fast inference over the wire. So that's why this gRPC is preferred over any other protocol. So if I want to go to this architecture of this, so yeah, this is basically, so you can define your gRPC server in any language. It can be C++, Python, or Java. Once it runs, you can create multiple clients using stubs. So you can compile and give the target to the stub that you want to create a Ruby client or a Java client, and then those clients can make the request to the server basically easily. There is a concept of protobufs. You have to define your objects, your domain objects in the specific language of gRPC. Like here we are seeing message person. It is having 3 attributes. One is name, ID, has ponycopter, right? 3. Then you have to define the service as well in the same pattern. Greeter, RPC, we are saying say hello. It takes a hello request and returns hello reply. Okay, then you compile them and you create the basically stubs and other things, proto things basically, which you can use against when you start the server basically. So this is, I think you don't need to delve too much deep into this. I'm just giving you some overview that we are using gRPC as our core building block for this inference API. So we have some steps to perform basically. So what we have to do, we have to first clone this repository. And then I think you have to do these steps. Let's first do these steps. Yeah, so please do these steps first. I have to go at around 11 basically, I think. Yeah, so you first you do these steps, and I think your setup will be smooth. Once it is done, then 2 options. So everything is inside the Docker build basically, Docker file. As you can see here, we have simplified everything inside a Docker file. So all the heavy lifting, all the hardworking stuff basically that you would do, we have already defined in a Docker file. So it is creating an environment, right, with the name faresec, and then it is installing some requirements, basically some utilities like wget, apt-get, pip install it is doing, and then ultimately it is giving a command that would run when you start this image, and it would basically run this server.py. So this server.py actually starts your server. So if I, yeah, and all the heavy lifting is inside the model, this model underscore bootstrap.sh file. If you go inside this file, there are a lot of things we are doing. It is installing dependencies, then it is using CanLM for language model, then wave2letter from web2 and wave2 infer, which is our repository. It is downloading that as well. Denoiser it is using, and then again some more utilities it is installed. So this whole heavy lifting is done automatically. You don't need to worry about it.
Rajat, this does not involve cloud, right? No,
this
is on my.
This does not involve cloud much, but if you want, you can publish your your image to the cloud repository. So a Docker registry, right?
Okay, so this can be done on my
So
local machine, like currently what you're telling.
Right. So what I have done already, I have pushed this repository to this account, this image to this ASIR DTH, ASIR, ASR IADDH account basically. I did that already. So this image is available already. So let's go through the steps to configure and create the images. Then I think we can discuss about this Docker pull and how you can. But yeah, I mean, to answer your question in a short, we don't need cloud right now. We only need cloud when you want to publish an image remotely so that other people can use. Only there. If you want to build your Docker image locally, then you don't need. You can build locally and run locally as well.
Okay, so this
think that
current,
answers.
yeah. So this, suppose if I have a like a small set of audio, so this will do the cleaning part on my local machine, right? That's what you mean. That is the SNR and the WAD SNR, and I get a cleaned audio after running this. Am I right or?
So after running this, you will get the response in the form of text. So once you give the audio, you will get the text. That is the whole purpose of this API, right?
Okay.
The input is the audio and the output is the text.
Okay. So in input is if I have a noisy audio, so this cleaning is also inside this only, right?
Correct. So if it is a noisy
Correct.
audio, it will try to denoise it and break it and give you the right. It will try to give you the text in the.
Okay. Okay.
So if I run locally, if I have that Docker run, yeah. So I already have this command, and I'll tell you how this can be done. But for now, I'm just showcasing you. Sorry. If I do ps-a, it takes around 5 minutes to start because it lost a model and all these things. It does. So the command I gave, I'll walk through all the commands in detail. I'm just showcasing you. Then I'll talk on the setup. So this command basically, this command you can say I can give the language. Oh, I think you might not be able to see it. You can see here, right? You can see the languages, right? I'm giving the languages that I want to build and the name of the container, and then I'm mounting my local path. So all my models are in this my local path. Okay. And I am mounting this path to the path in the Docker file, Docker image. Okay. And then I'm giving the name of this image that I want and the version basically. So this is how I run my container. Okay. And now you will say where this path is used, this path basically inside this path, the highlighted path, where it is used. So this is used.
Yeah,
Yes.
Rajat, some people are not able to clone into the repository. They are getting a permission denied error. Is it a private repo or?
No, basically you can fork it. You should be able to fork it, no? Can you?
I can able to download it.
I think we should be.
Yeah, I can also download it.
Cool. I think this public key you are using, do you have the public key there? I mean, oh, are you using HTTPS or what? If you have been using HTTPS, please use the HTTPS. I'm giving you the repository link directly. The way you have downloaded, cloned other repository, please clone this the same way. Just a minute. And you can fork it first rather than downloading that. Oh yeah, I'm giving you this whole browser. You can do it's already there. Thanks. Cool. So what I was saying, basically, you can see these commands. I'll walk you through all these commands. I'll try to run all these commands on your machine. But for now, basically, these languages have to provide, and this path basically that I mount from my local, which has all my model artifacts like model file, language model file, and everything. And I'm mounting to this path, deployed models. So if I go to the dictionary, so this is where we define the dictionary for the model. So let's say for Hindi, I want to run the Hindi model. So I have given this path, right? Deployed model, then Hindi and Hindi.pt. So this would search my model in this path. Okay, but here you can see on my local, I have mounted my local to this path, right? So these models will be mounted and will be available on this path inside the Docker image, Docker container. So that is how we are mounting the path. And once you run it, you will get some your server running basically. So let me just see the logs. Ultimately, you will see.
Rajat, will you mounting your path to the Docker image?
Yes. So
when you
this
are
path,
create actually that is creating container to container, you are mapping your path, correct?
This is my local path and this is the path inside. Okay, this one basically.
Okay.
Okay, so this path is used actually. If you see here also we have defined the path.
So in my case, I can't run this, no, because I may not have that model, no.
You don't have the model. I'll tell you all these steps. It's just a theoretical session. Sort of,
yeah. Okay. No issue.
So I think this should be already be running now. And how do we run it? Basically, in the examples, we can go inside the Python in the main.py. I can change my server to localhost because it is running on my localhost, right? And I can just go there and I can say Python examples. They should run, I think. So it is running two files. One is for URL. Basically, one file is already on a remote URL on HTTPS. So if you go inside, one wave file is already present inside the on this path. So it is trying to transcribe this. The other one is already in my local machine. Examples. Yeah. So other one is the audio bytes. So audio byte is nothing but it reads the local file, which is this change.wf file, and it gives the request as a bytes to the server. So you can see here, it is reading my audio file from local machine. If you can see this change.wf file, which is there, right? And it is, we are creating the configuration using like this on line number 85. We are creating the configuration that this is the language is Hindi. It is sort in format wave file, and we want the transcription format in the SRT format. It can be text as well. If you want just a text format, then it can be text as well. And we are enabling the inverse text normalization and the punctuation as well. We can enable, basically we can give this configuration as well there. More configurations are there, we'll discuss more. So yeah, this is, and then we are saying stub dot recognize is the method. So this stub is the client. This is the gRPC terminology, right? Or it's any remote procedure call framework, they use stubs. So using stub, I am calling the server. So it is like appearing like we are making a local method call, but it is not a local method call. It is going to a server, and where the server is running right now, it is running on my local, right, local host. And you get the response, and we are printing the response here. So that is how this whole end-to-end service basically that we are saying it is running. So you can see we have got the response, right? These responses we got. So yeah, this is basically just to make the using our models over the internet, because this whole setup and everything is very cumbersome. Then it's not feasible to run it locally, right? To give the remote support. So that is how we are doing it. And out of the box, it is doing a lot of other things, like it is doing inverse text normalization, which means it is normalizing your text. So let's say you are speaking some numbers, right? 10,000, 50,000, everything. So it is normalized to a particular numerical form. So that is what we are doing. We are also adding punctuation. We are doing. So all these things are done as a part of this API, on which basically we have a lot of research and it worked on that. Basically, we have come up with this right now, which is, it looks good to be used in production grade application now. That's what we feel. Very soon we are going to deploy it in the government infrastructure, where it will open it for multiple startups which can consume this API. That is the plan. So I think for the theoretical session, that is it. Any other thing that you want to discuss, Anirudh? I think more detailed setup and all. I've already given you some commands. I will give you more commands. Basically, try to run this build locally. This is kind of image locally, if you can. Once you are done with the other steps that I sent earlier, right, above, clone repository, then conda create environment, pip install. After that, you did this, do this all steps. Basically, try to. I think let me just read this. Can I delete it or not? Okay. Ignore this. Or above. That's it. So instead of this thing, do simpler thing basically.
So we have to install Google Compute Engine and all this.
This might not be required. I just kept it. Let's see if it is. So this activation of service account is not required actually, because you are using your own account. Then you can use your own.
No, one account means will we run this in our Google Cloud or? Okay.
So
local machine we don't need this, is it?
Yeah. So basically, what you want to do is you don't want to push it to any registry on the cloud, right? So that you don't need all these setups. That's what the initial question from. Initially the question when we joined this call, there was a question. So basically you don't need cloud. If you can build locally, if your machine is allowing you to build, like you have the space and all the resources, then build it locally and that's it. You can run it locally.
So what resources actually you need? Means for that locally building?
Storage, mostly storage. It will eat up your storage. I tried on my local machine.
How much storage it is?
Might take a lot, like 10 to 15 GB. If it is there on your machine, then it's fine. On my machine, I'm always in crunch of the storage. So
10 to 15 GB.
You can try it out.
Secondary memory, correct? It's not RAM, no?
10 to 15 GB, maybe 20 GB. No, not.
Rajat, during inference, are you using GPU or CPU? Like which?
During inference, no, we are using CPU right now.
CPU only.
But it can be run on GPU as well. We have tried it. Right now, we don't need GPU. I mean, it's just for demo, and we have used it on CPU, and it works very well on CPU as well. CPU is only required when you need very low latency and you want to support a lot of users.
Okay. And the input of that API is base format, right? Not in wave format. Like bytes you are giving, right?
Input of the API is the like we are having the wave file, but the bytes are from the wave file only. Bytes are byte, just byte, right? But it reads the wave file. Ultimately, it has to be wave file.
Oh, wave file only. Okay. Okay, can you explain like once about the gRPC once?
Yeah. So you see the gRPC, gRPC gives you the capability to do the remote call, right? If you see our client, like this is our client.
Okay.
So here what we're doing, we are creating a stub, object of a stub, speech recognition stub, right? And we are using that stub, and what we are doing, we are sending this, calling this recognize method, correct? We are calling this stub.recognize method. This method to anyone would look like it is a local call, right? It is not a local call. It is a remote procedure call. Okay. We are calling this method on a remote machine or over the internet. So this is remote procedure call.
Okay. Okay.
Okay. This is the fundamental of. This is how the applications can interact with each other. This is the one way. One way is the REST, right? REST, REST over HTTP.
I don't have much idea, but like that flags based, all those things are REST API, right? Flags and fast API.
Correct. So REST basically you give the request as JSON format, right? And you get the response as JSON format using GET or POST request, right? Here there is no concept of GET or POST or anything. It's just a call of the method.
Okay.
Right. So this is the client side of the code. When we go to the server side of the code, in the server side, you have to define this gRPC server. Okay. And you do a lot of things, like you define where it should run, what is the port number and all. Then you also define multiple other things, like in the photo things, you will see that. Yeah, so you can see this is how you define your service.
Okay.
What I'm saying is, I am defining my service speech recognition. It would have one method recognize, and it's a remote procedure call. It would take speech recognition object as input, and it would return speech result as an object. Okay. So this is the template, or you can say this is the structure of my service. That's how I define in gRPC. This is my you can say domain ideal. It's a domain specific language for gRPC. You have to define these services. Somebody have to write this code that this request will comprises of two things, like speech recognition config and audio. Then how the speech recognition config structure looks like. So it has transcription format, like it can be transcript or SRT or alternatives, or what sample rate it can take. So all these things are kind of defined in this file, all the specifications. Okay. Then using the gRPC command, you create the server. I mean, you have to define the implementation of it somewhere, right? So this implementation goes inside the model service here. So let me connect the dots. So you can see here, right? Speech recognition we are saying here. So this speech recognition recognizer is basically defined inside this. What do we call this service? Speech recognition service. Here it is. This is the definition. This is the code actually, actual code inside this speech recognition service.py. Okay, there we find the template only, right? Here we define just a template.
Okay.
Here we define the actual code, how it will run basically. Okay, and then when we defined everything, we create the stubs. So when you run a gRPC command locally, it will create some stubs for you. Okay, so that stubs you can keep, like you can publish and you can use in the client side code. That is how is the basic gRPC works.
Okay.
Yeah, I would suggest to read it some, like for more, if you want to go deeper.
Yes.
Cool. I think I need to go. I'll connect. Maybe Anirudh, do you want to take further this session, because I need to go. I'll be available for the hands-on session. Hello. Yeah, I need to go. I'll be available now at 1. Meanwhile, I think whatever the previous days discussions we have been doing, you can do that, and if you want to continue this, you can also continue. I need to off. Okay. Okay. See you then after some time at 2, maybe sorry, at 1 I'll come back. I hope that is fine. Okay, thanks. Bye everyone. Hello. Hello.
Hello, yeah.
Yes,
Hello,
yes,
yeah.
Sachin.
Yeah. So hi. So should we go over doubts from yesterday? And there were some doubts, and we wanted to some questions around BAD and SNR using simple script. We can basically take that. Do you want to do this now or at 11:30? Or do you want to do it?
Mr. Anirudh, I have a doubt. Can I ask now?
Yeah, sure.
So yesterday we were running this training,
Yes.
and for how many epochs it should run, or it will stop automatically, or we have to kill it?
No, you have to kill it. So there are some number of steps which we have specified in the config. So it goes till those steps. But if your WER has basically converged and it's asymptotic, then we can kill it.
Actually, how to know how much WR I have? Now my epoch is 50.
Okay, so your WAN-DB is working or not working?
1 DB is working, yeah.
Yeah, so you can have a look there, right? In the valid set, there will be a valid WER, so you will be able to see what's the WER.
Valid WPB is there. Training.
Yeah, you can share your screen, maybe.
Yeah. I'm sharing my screen. So can you see this?
Yes. So there are 3 runs I see here. Which run is currently running? I think the green one. Yeah. Click
Green
on
one.
this. Yeah. Click
Yeah.
on this. Yeah. So scroll down a little bit.
Yeah, best WER here
So
is.
best WER is this, and there will be some WER as well. Just so go up. Yeah. So WER is not here. So there are just six plots from the valid. You can click on. So there was an arrow, down
Here.
arrow. No. On the right corner, 1 to 6 of 11, bottom right corner.
Yeah, clear.
Yeah. Click on that. So yeah, so your WER is currently around 20. It's still decreasing, right?
Okay.
Seems like so. You can keep it running for some more time, or you can,
Yeah. So let it run for some more time. Let us see if it is.
Okay.
Okay. Thank you.
Yeah. Yeah, there's a question. What is the difference between epoch and batch? Okay, so epoch is basically so epoch is so your basically your model has to see the whole training data. So we have to basically keep feeding model our batches, our data into the model to basically so that optimizer learns which direction to take, right? So epoch happens when your model has seen that training data at least once. So when one cycle has finished, that's called an epoch, right? And batch is the number of examples from the training set you are actually able to feed on the GPU, and that depends on the size of the GPU. Okay, so if your GPU is 4 GB, your batch size would be low. If your GPU is 16 GB or more, if you have more GPUs, then your batch size will be high. So that's how batch size is divided. So if you have a higher batch size, basically you will go through an epoch faster, right? Because you are able to load more training examples in one go. I hope this was clear. Okay.
Uh, in the that speech recognition API,
Mhm.
you have that is codementor.com.
Yes.
So there are English, IN means India. Another is bio English. What does it?
Yeah. So I had shown yesterday, right? So that is the same acoustic model, but with a different language model, and we were able to adapt it to our domain. So it's just the language model is basically generated from a lot of PubMed articles.
Okay.
Yeah, so
So
it's able to recognize
why the
many.
name bio is given?
It's just just like that. It can be anything.
That,
Yeah,
that is confusing.
yeah. So it basically catches medical vocabulary better than the regular English model.
Okay, biological
Yes, yes,
kind of thing. Okay. Hindi, Tamil, Bengali, Nepali, Kannada, Gujarati. And you will go on adding other languages soon, I hope.
yes.
Okay, very nice, very nice, very nice.
Hello, Anirudh?
Yes, Vishwakuma.
Yeah. Will you be will we be getting to know like how to be deploying this code if you want to deploy like what model like currently we have built? So that information will be given sometime.
Yes, so the
Like,
API is basically doing that only. So, uh, so currently we have not integrated this API with a UI. I mean a front end, but essentially it can be done. The current, if you are talking about how we are hosting the models in Codmento, this website and all these things, that code is open source, but I don't think we'll be able to go through that code today, because that is also a lot of, although the code is open source, interested readers can have a look there, but it will be difficult to go through that, I think.
okay, suppose if we want to deploy a model, what we have built, so we should be using we should be following the similar way, right? Something what you just said, like, can you just share the link of that one?
Yeah. I will share. So this, so how we have deployed models currently. So this is all very experimental. We have to fix a lot of things, and eventually everything will be done using the API which this project talked about. Okay, so just for testing out, we had basically written this wrapper, and I'm sending the link here.
Okay.
Yeah.
Yeah.
But it doesn't have much documentation and all these things, because this is very temporary. We will move to permanent solution using the API. So that's what.
Okay.
Yeah.
No, yesterday, like you were telling about that single file inferencing, right? And
Yes.
you were telling about custom models we are
Yes.
building.
Yes.
Yeah. So,
That we can go
okay.
through. Yes.
Okay.
That is fine.
Thank you. Yeah.
That we can do. Another another method is like, once you have the custom model. So currently for inference, we are using two models, right? The pre-training one and the fine-tuning one. So once you have a custom model, and you can write your own Flask API endpoints as well. If someone doesn't want to, go through this whole, they can basically use the same thing and type their own service around it.
So we can do it with WASP API if we the whatever this custom model.
Yes, you can do, but the challenge would be in basically getting the mic stream using Flask and all those things. So that is something we have not tested out yet. So
Okay.
currently, how we are capturing my voice in the microphone in the browser is using the JavaScript library, and that is not Python or Flask. So yeah, that
Okay.
that can be a little challenging, but yeah, it should be possible.
Okay. Yeah.
Mr. Anirudh, I had already requested earlier. Again, also I'm telling.
Mhm.
So, if we can get a flavor of how to create the data set actually locally,
Right.
so for a newbie like me will be greatly helped. Suppose a audio,
Sir.
10-minute
Yes, sir.
audio is there. How
Yes,
can
sir.
we make
Yes, sir.
this?
Yeah. So, sir, we created some scripts for that actually yesterday after the
Oh,
workshop. You're working on that, so
very nice, very
we're able
nice.
to do something. But it's not the whole pipeline. So it will basically take a long audio and it will cut it into voice chunks using voice activity, and then it will calculate the SNR, and then you can basically check what chunks to keep or not, right?
Okay.
But there were some other parts in the pipeline like speaker recognition and language identification. That part we were not able to integrate in one day. Uh,
Yeah,
so
definitely. But whatever
yeah,
we can do locally,
right. That
so
that that is possible, sir. So WAD and SNR and chunks getting chunks, that we
now
can do.
before going to this large scale pipelining,
Right.
to clear the concepts, if we can make it locally,
Mhm.
so then we can have a feeling of that actually what is
Mhm.
happening in the.
Right.
Okay, thank you, thank you.
Yeah.
Hello, sir.
Hello. Hi, Ganesh. Yeah.
Hello, sir. Is this API publicly available? Open speech? Sorry, egg steps.
Uh, Eight step open speech. Yeah. Rajat basically pasted the GitHub link, right? You are asking about the code or?
No. The like, I assume I have some certain
Mm.
certain audio files. I just want to
No. It is
transfer
not
to.
publicly available yet. It is not publicly available yet. But I think that is also told that all these APIs are going to be hosted under the government infrastructure in some time, where local startups or people who want to use the API can use it.
Okay.
Yeah.
So that's
Currently they are not hosted. Yeah.
okay.
That is the
So
reason.
then the whole process again, like we have to pick the model, take the fine tune model, build a inference around it, and
No.
then
So if
use.
the APIs are already hosted, then you just need to send a request, right?
Yes.
You don't need
No,
to.
yeah, my point is like to use the X steps solutions, we should download the fine tuning model
Yeah.
and do the inference process and make it work, right?
Yes.
Okay, so there isn't any publicly, I mean, you didn't push it in public domain yet.
Public domain, the
The
API.
API format, like how the Google is giving, right? Google underscore recognition, something.
No. We have not done that. So we are not hosting the models for public usage yet. Otherwise, the volumes can be
Oh,
enormous, right?
okay.
Yeah, we are providing the models, the all the code and everything. You can set it up in your own infrastructure as of yet.
Okay.
Yeah.
Thank you.
Anirudh, I have
Mhm.
one question.
Yes.
Okay, here, like whatever the API currently you are is in live, so that how many requests can handle at a time? Like
So you are asking about the website?
yes, whatever that
Yeah.
day you show that demo, right?
Yeah, the demo. Okay. So currently, this is all very experimental, just for
Okay,
eight step folks. So we have loaded all these models onto a single GPU of
okay,
16 GB. Okay.
okay,
So
okay.
each model is around 350 MB, right? So it takes up some space, and then we were
Mm-hmm.
able to do some crude load testing around it, and it was able to handle 20 to 30 concurrent requests.
Oh, concurrent process.
Yes,
Okay.
on GPU.
On
Uh,
GPU. Okay.
for real time inference. Yeah,
Okay.
but yeah, this is very experimental. This is not a scaled version.
Yes. So, and another point, like this web to web model footprint is very large.
Mhm.
Whatever the model currently
Mhm.
you are building, that is I think 1 GB or something like that.
Yeah.
And web to web that large model, whatever Facebook release, so that
Right,
is around 3.8 GB.
right,
So,
right.
are you using some kind of like compression techniques for knowledge distillation or something
Mhm.
like that?
Mhm. So currently
Okay,
not. So
okay.
when we are building the custom model, we are actually fusing the pre-trained and fine-tuned model and basically dropping the parts which are not necessary for inference.
Yes, yes, exactly. I saw actually that thing.
Yeah.
Yeah, the pre-trained model also you are using for inferencing.
Yeah. So pre-trained model for inferencing only, but after you have made the custom model, the single file inference model, then you don't
Okay,
need the pre-trained model, and that model is around
okay.
350 MB for us. Okay. That
Oh,
is
okay,
already
okay,
much
okay,
smaller
okay.
than wave to wave. But of
Yes,
course,
yes.
this is the base architecture. If this is a large architecture, then I think it should be around 600 MB or something.
Mm-hmm,
So we
okay.
have not started working in the direction of doing some quantization on top of it, but
Yes, yes.
we'll have to do it in some time. So
Okay,
that is in the
okay.
plan, but we have not done it yet.
Mm-hmm. Okay, okay,
Yeah,
okay.
we want to do some quantization on this also.
Okay, okay, fine. Thank you.
But
Hello,
this,
sir.
Mhm.
Yeah, yeah, proceed.
Yeah, tell me.
Yeah. No, what suggestion would you give to the new thing? I mean, new people. Like as of now, we are just hosting it some using some WebSocket in some server and then pushing it with a uh, dynamic IP. Which one would be the best way? I mean, we need to also take care of this load balancing, all those things, right? What
Yeah,
suggestion would you give?
I don't have much ideas around this.
No,
So
the
yeah,
problem is like there are multiple requests being hitting
right, right,
simultaneously.
right, right.
So it is becoming very hard to like balance that one.
Yeah,
And I mean, we are just using WebSocket and we have just hosted it.
no, 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 that
And
yeah. So
yeah,
I think like architectures like you, Rajat, and you were talking about Kubernetes and things like that. These things will
yeah.
be able to do load balancing much better than manual sockets. So yeah, but we have to basically figure out that as well before publishing it.
Okay. I mean, what would you suggest? I mean, as of now, like we have just only Kali based models in WebSockets.
Hmm.
So we are planning to migrate everything to this end-to-end architectures.
Hmm.
So should we go for RPC protocol or some other things?
So
I
gRPC,
mean,
yeah.
yeah,
So
I mean to maintain the balancing also, load balancers properly.
yeah, I think you better ask this question to Rajat. I'm not the right person to answer this question. Yeah.
Okay, okay.
So okay, so I think Priyanshi is also here. Priyanshi, are you follow?
Yeah, hi everyone.
Hi. So we can demonstrate this pre-processing of data using WAD and SNR. I think many people ask for that. So if people can log into their instances and we can demonstrate with that and maybe answer some of the doubts from yesterday if people have. Is that fine? Jagabandhu or
Yes, please
Anirudh,
go ahead.
okay, okay.
Anirudh, this is we have to log into our instances. Means,
Yes, 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 yes. I'll switch on the instances. So
no, I mean this was for locally, right? What we thought, or is it in our local PCs,
you
or
can do it in the local PCs as well. Actually, you don't need the cloud. So this is very
okay,
lightweight.
okay,
What we have developed. Yeah, you
okay,
can
okay,
you can do it in
yeah,
the local as well.
okay, okay.
So I will just first paste a repo and then I will demonstrate what to do. Uh, ah, so if you can basically clone this repo on your systems first. Yeah, once you have cloned it, you need to install these packages also. Okay, so I will share my screen, and I'll just also just do it from scratch just to test it out. So I'll just clone this from there. Is my screen visible? Yeah.
Yes,
Yes,
it's
yes.
good.
Okay. So yeah, I just cloned this. I'll just install these things again just in case. WebRTC already there. Sound file there. AQDM will be also there, I think. Okay. Then inside common scripts, you have to go to the miscellaneous folder. So I'll just paste the commands. So those will be cd common cd miscellaneous, I think. Once you are inside this, you will see some a lot of files. So first, so we have also put a sample audio inside. So let's just check what it looks like. So the duration is around 9 minutes, right?
Can you please increase the font size of the terminal?
Okay, let me try.
Should we
Yeah,
download this common scripts?
yeah. Is it better now?
Yeah, better. So should we download this common scripts?
Yeah, you should clone this.
Yeah, clone.
Yeah,
Then and any environment required for this, or
yeah. I pasted 3 libraries. You can install those.
and Conda activate and all these things are not required.
I mean, it depends if you are using a Conda environment in your local or not. I don't know. If you have,
Yeah,
then well and good. If not, then I think pip should work anyways.
I just now created for Rajat. Okay.
Yeah. So yeah, we were looking at this audio file. So it has some duration. It is a long file, right? It has all these things. So first we will basically split it using voice activity. Okay. So for that, I need to know how do I run it. So if you just try to run it, if you throw an error because it needs all these parameters, right? So it needs an aggressiveness. So this implementation of voice activity detection needs an aggressiveness. So aggressive means what is the silence value in between chunks, such that it separates these voice chunks. Okay, so if it's more aggressive, then the silence duration is less. If it's less aggressive, then the silence duration is more. Okay, so that is what is meant by aggressiveness here. Then you have to specify the WAV path, any file, 1 hour, 2 hours, I mean, whatever, it can be anything. And basically this will be the sample audio here. And then you have to specify an output path where you want to store all these voice chunks. Okay. So if I just run this, try to run this, let's see if it works. So minus A. So the aggressiveness values can be 1, 2, or 3. Okay. So let's say I want to be most aggressive in creating chunks. I'll give it as 3. Okay. Then I do minus W, then sample audio. And then I have to specify an output path. Okay. So I'll just call it as voice chunks. So let's see if it creates something. Yes. So if you see, now it has created a folder known as voice chunks. Okay. So if I go inside this, you see all these chunks, and all the non-voice chunks have been rejected. So they have not been stored here. Okay. So if I look at the duration of any chunk here, so it would be 1 second, right? Something like that. We can also try to listen to it. Baat bhi honge, right? So this is how it works basically. Simply just we have to specify all these parameters. The aggressiveness you have to pass in the WAV file, you have to pass an output folder, and it will basically save just the voice chunks inside. Okay. It has created 67 voice chunks.
Please paste the command in the chat box.
Okay.
Anirudh, it is default is 1 second.
No, default is not 1 second, sir. We can.
So where we have mentioned 1 second, like.
No, we have not mentioned 1 second anywhere. So how did you think it's 1 second? Because of the duration of the chunk. So the duration of the chunk can be anything, right? If the voice activity is longer, it can be larger, right? So
Okay.
yeah. So
also from out of utterance, it is selecting basically voice regions.
Exactly.
Okay.
Exactly. And what we are using is this version. So if I paste the original library, Python var, if I just type it, will show up. So basically it is this one. So it's hello. Yeah.
So Valdo. So what is the threshold time for silence?
Right. That's what I'm trying to tell here. Okay. So the library we are using is this one at the backend. So PyWebRTC VAD. So WebRTC is another framework for multimedia developed by Google, and they developed this VAD also. It's lightweight. It works for our purposes. So if you want to read more about it, you can basically go to this library. Okay. It has a lot of other functionalities as well. Somebody has an error. Let's look at it. So your question was, what is the duration of the aggressiveness, right? It's given here. So optionally set aggressive mode, which is integer between 0 to 3. 0 is the least aggressive, about 3 is the most aggressive, and you can also set the mode this. And what is the duration of this aggressiveness? Let me just try to look at it. I also forgot. So if I go to this and
Hello, Anirudh.
hello, yeah.
Can I help here?
Yeah.
Actually, the frame will be around 10 millisecond. Okay, if it's frame duration is 10 millisecond. If it's a 16 kilohertz sampling rate, and the frame duration will be 20 if it is 32. This is what the Google WebRTC does.
Okay.
So accordingly, it get calculated. So sampling rate into frame duration divided by 1000 will be the number of frames.
Yeah, exactly.
So based on that one, they will raise a flag. Wherever there is a silence, that will be 0, or unvoiced, it is 0, and voiced, it is 1, based on the decision. This is what the WebRTC documentation says.
Yeah, but also like if we give web aggressiveness as 2, then the
Yes.
silence duration is 20 milliseconds in that
Yes,
case.
yes. Actually, yeah. If
Yeah.
we see the implementation, it's a moving average window. It is not a static window.
Yeah.
So, yeah.
So it collects these chunks, and in that it basically you have to define a percentage that how many chunks are
Yes.
voiced or not, right?
Yes,
That's how it
yes.
is calculating that.
Yes.
So yeah, I forgot this 10, 20, 30. So
Yeah.
if aggressiveness is 1, the silence is 10. If aggressiveness is
Yes.
30, it's 30 milliseconds. Yeah, that is what is happening inside this. Yeah. So after this has been done, so there are some chunks inside. Let's troubleshoot. Some people face some errors. Yeah, were you able to resolve this error or not? Usmita. Hello. No. Okay.
Hello, yes, sir.
Yeah, maybe you can share your screen, then we can try to.
Yeah.
Yeah.
Okay, sir. Is my terminal visible, sir?
Yes. Can you make it a little bigger? Yeah. Okay.
Sir.
Hello. Yeah. So when you are doing this, you got this is okay. Which Python version are you using?
Sir, 2.7. Yeah, it can be because of that.
Yeah, I think you need a Python 3 version for this. That's why there's this error.
You can compile with Python 3 webrtc.py.
Okay.
Yeah, instead of Python, try
Already
Python
sent that.
3 if you have installed. Yeah. Can you
Okay,
press
sir,
up
I
arrow?
installed. Thanks, sir.
Yeah. Okay. Yeah, you will have to run it
Okay.
Python 3 instead. Yeah, that's the only thing. Yeah. Okay.
Okay. Thank you, sir.
Okay. Yeah. Okay. So yeah, once you have the voice chunks, basically, we have to now run the SNR utility on. So basically,
Hello, sir. Hello.
Yeah.
Yeah, I have a doubt. Like, you were mentioning about aggressiveness here. So, what actually, like, 1, 2, 3 resemble there?
Yeah. So 1, 2, 3 means 3 is most aggressive. So if I look at the example, so when I had run this, I had given aggressiveness as 3. Okay. And the number of chunks it created inside the voice chunks was 67. Okay. Now let me try to do one more thing. Okay. I will basically remove this voice chunks. And I'll basically try to do the same thing, but with aggressiveness 1. Okay. You'll see the difference. So if I do it with aggressiveness 1, and if I go inside voice chunks, you see only 13 samples are created. That means the duration of these chunks have increased, right? That means the voice activity was not as aggressive in cutting the audio into voice chunks.
Yeah.
That means that it is Yeah, understood.
Hmm.
Yeah. So if you do it on 2, it will be a number between 13 and 67. Okay, it should be. I mean, so
that means it is this threshold will be less. Is it? Is it?
threshold. Yeah. So if the number of samples is less, then the threshold is more, right? Then the threshold
Okay.
is more. Yeah, I think.
Okay. No, number of okay. The number of chunks you are telling this will be less.
Yes.
Number of chunks will be less means you have given this. Okay. Yeah. Threshold will be threshold. If you put less, then this will be number of chunk will be less. No.
So if
Okay. The
threshold is
number of hoist frame we will get higher. Correct. On hoist.
how I understand this is that suppose your threshold is 0.01. Okay, that means that even on the smallest of silences, it will basically split the chunk, right? And if the threshold is, let's say, not 0.01, it will be 0.3, right? Then it will, if anything between 0.01 and 0.3, it will keep appending that in the previous chunk.
Correct.
Okay,
Correct. Correct.
so that
So
is
that
my
means,
understanding.
yeah,
Yeah,
that means you are telling that if the threshold is higher, then you will get less number of this one
right, right,
chunks.
right, right.
Okay, okay, okay. So this aggressiveness is this one threshold only, or what?
It is a threshold, but yeah, how this mapping is done to 1, 2, 3 in the backend, that for that we need to look at the code also.
Okay,
That is what
okay.
I was looking. Yeah. So we have voice chunks now, and we just want to run this VADA SNR. So SNR is also, a signal to noise issue. There are various ways to do it. We found this method to be effective. It was basically easy to calculate, also very fast. We could scale it. It worked for a purpose. So we are using this VADA SNR. So if you look at how to run this file, so if I just try to run it, yeah, so I need these inputs to run this, right? The input folder and the path. So basically it's a C++ library, okay? And so this is inside this folder. So VADA SNR. So you see this is all already we have placed inside. So we had copied the code into our repo so that people can use it. So all we have to run it is that Python -i input folder, so voice chunks, right? And -w, you have to give VADA SNR, the folder which contains the C++ code. Okay. So if we do this, there is some problem. Okay.
VADA SNR.py.
Sorry.
Yeah.
Okay. So it calculates and basically it saves to a file. So if you look at it now, there's a CSV file here which is called SNR values. Okay. So with each chunk inside voice chunks, you have an SNR value. Okay. And now you can decide which audios you want to keep and which audios you want to reject. From our experience, we have seen that with VADA SNR, if something is above a threshold of 20 to 25, it is usually very clean. So anything below that, we reject in our pipeline.
Please paste the command.
Yeah. Okay, for Sushmita is still not working. You can try to troubleshoot. For everyone else, it's working, or it's the VADA SNR as well. We can basically do a lot of things now once we have this. So if I just open this in a notebook, we can try to have a look at the distribution and all those things. So if I just do this environment is a little screwed.
And please increase the size.
Oh yeah. So I'm just trying to read the CSV file and trying to look at it. Nothing very special, but yeah. So if
Okay, how to check the SNR values calculated? Head of how using
head. Yeah. Cat or head or whatever you use tail. I mean, just to look at a part of the file, right?
then what the capital SNR that file name will give?
SNR values.
The CSV
Okay.
file name is SNR underscore values, SNR
Oh,
capital.
SNR underscore values. Okay.
Yeah,
Right.
you can change that inside the code if you want, right? So
Okay.
this is the basically file which shows up, right? We can try to look at the distribution. Call it. Yeah, so yeah, this is the distribution of the SNR. So you see that it peaks around 30. So most of the chunks inside are greater than 20 to 25. So you can, what we have seen is you can reject something which is less than 20, less than 15, and you can try to keep the rest of the chunks, right? So this is how the distribution looks like.
Can you paste this code also in the chat?
Sure. Yeah. Yeah. So yeah, please repeat these steps. If anybody is still facing some problems, we can troubleshoot. So yeah, if most of the people have done it and don't have any questions, we can move to creating this custom model we were talking about. Okay. So should I switch on the instances, because I think the models of everyone are on the instance, right? So, Jagbandu sir, should we do that, or
Yeah, we can switch on the instances,
okay,
sir.
okay, okay, okay. Instances are almost started. Um, so someone was facing some issue in group 3, right? I think Salam was facing an issue. Is Salam?
Yes. Hello.
Hello. Hi. Hi,
Yes,
Salam.
sir.
Yeah. So I was
Sir.
able to, I was able to fix your instance. You just need to do one thing. So instead, just try to log into my username instead and then use it. Okay. So if you do sudo su anirudh, I have pasted the command. So you just do that and then conda activate pair sec, and inside my username, you will see all the training files and other things. So that
Okay.
should
Okay.
okay.
Mm-hmm.
Just see that.
Sir, I already log in my username.
Yeah,
So
still
I'm
you can do
doing.
that. Still you can do that. Sudo su anirudh.
Okay. Okay.
Yeah.
So what is the problem for using my username?
I so your conda environment is somehow not working even still after doing all this. So I was able to fix it on my username, so you can basically log
Okay.
into that.
Okay.
Yeah.
Sir, what is the procedure to go to your username?
Yeah, I just pasted the command sudo su anirudh. You will be able to go
So where I have to in my terminal.
in the terminal you have to paste it. Yes. And then you can do conda activate fair sec.
Group number 3, I have to type sudo su anirudh.
Yes.
Okay. Okay.
It is given in the box, Salam bhai.
Yeah, in
It
the
is
chat
given
I've
in the
pasted.
box. Everything is given. Conda activate is also given there. You simply follow that one, then it can be run, I think.
Okay.
Yeah. So everyone is logged into their instances, then we can basically So I think group 3 doesn't have still the best checkpoint. So I'll just copy
No,
that.
no, sir. That is because that instance problem, na.
Yeah.
We are unable to do it. Now I think we can do it. So after some
Yeah.
time we can have the result.
I will copy the best checkpoint there.
Okay.
Yeah.
Then we can run from that particular checkpoint, na.
Yeah. I will copy
Okay,
that
sir.
checkpoint in your PDF.
Okay, sir.
Yeah.
Thank you.
Yeah, no problem. Yeah, so I've copied the checkpoint to group 3 instance as well. Maybe I think Priyanshi can share her screen and demonstrate what to do, and then people can follow, right? Okay.
Okay.
Yeah, custom model has to be done in the GPU. It's on the instance if it's better. Yeah.
Okay, so let's start if all the instances are open now. Okay, So let's go to the Vakyansh Wave 2 experimentation repo. So now we have to build a custom model for the single file inference. So I will go to cd scripts and inference. I'll do an ls. So I can see that I have a file called generate custom model.sh. So first I need to create my custom model. So I'll just do vi generate custom model.sh, and then here we have the custom model name. So it's written final model here. Let's make it final model itself. Then fine tune model path is my checkpoint west model path, and my pre-trained model path will be the one which I have used. So currently I have not used checkpoint west. I have used my other multilingual pre-trained model, and the name is CLSRIL23.pt. So I will change these two parameters. Rest I will let it others to remain. The directory would be custom model directory, and my dictionary will be taken from my fine tuning dictionary because we need the same dictionary on which we trained our model. So this is it. I will paste what all you need to change, and then we can do the generate custom model.sh. Okay, I forgot to activate my environment. Wait a sec. And now generate custom model.sh. So this is generating. Meanwhile, I will give you my commands.
Hello, ma'am.
Yes.
Yesterday I have completed the Viterbi mode. Then, and language model is not completed due to instances close suddenly. So right now I am running language model. So it is required to complete the language model, then go for these steps, or otherwise I can quit it and go for this step.
If you want, you can do it without the language model also right now. We can integrate the language model later on.
So TNC, will we have to change anything in generate custom model.sh or directly?
Yeah, so you need to change the pre-trained model path because the name is something else. So instead of checkpoint west, you need to put CLSRIL because that was the name of our model. So just the path that was already there and the select.
Pre-trained model path, is it?
Yes, yes.
Dianshi, it's better if you copy the exact path.
Okay.
Yeah, just copy the exact path from the file. Just cat it first, yeah. Okay. I just copy the, because it's same for everyone, no, currently.
Yes.
So we can just paste it as it is.
Yeah, you can take the second one.
Yeah. And the fine-tune model path also. Yeah, checkpoint best. You
Yeah,
didn't change it now?
No,
Yeah.
I didn't change anything else.
Okay, great. Yeah.
So
you just have to change the pre-trained model path inside this script, generate custom model, and try to run this script, and it should run for most of the people. So just let us know. Yeah.
What is the difference of that fine-tune model and custom model? Like, are you changing anything or?
Yeah. So while inference, basically there were some parameters in the pre-trained model that were loaded while inference. So we are just copying that manually, so we don't have to load two models at once.
Okay.
And then we are dropping some optimizer information because we don't need that for inference. And that's why the model size has reduced from 1 GB to like 350 MB.
Exactly. Okay, fine. Thank you.
For more details, so if you just open the script, Tianchi.
Yeah.
Yeah, of course, if someone is well versed with PyTorch, they can actually have a look at our script which we are using. So in the utils inference, there's this generate custom model, and it is exactly written what we are doing there. So we are loading both PyTorch models, merging some parameters artificially, and dropping some things. So it's there. Yeah. So optimizer information is useful when you want to resume training from that checkpoint. Otherwise, the learning rate and all those things are lost. Right? We don't need them for inference.
Okay.
Yeah.
So something like this will be shown after your custom model is generated. It will show completed and it will show the path where it is saved. So please let me know if all the groups are done and then we can move forward with the single file inference.
Ma'am, I think your screen is stuck. Yeah, now.
Oh, is it? Okay. Okay, let me share again. Okay, is it visible now? Is my terminal visible?
Yes.
Yes.
Okay. So if you can see over here that the generating custom model, and then it will show you the path where it is saved and it will show completed. So after you have seen that there is a completed written over here, you can just let us know in the group and we can move forward. So the custom model will be created in checkpoints. So I'll show you checkpoints, custom model. So if you can see over here, we have the final model.pt, which is our custom model. And we also have the dictionary. So the dictionary is copied from the fine tuning path. So I can paste this command. You can have a check if your custom model is present over there. Okay, so a lot of groups have done. A few more to go.
Nirad, is it possible to tell you that in generate custom model.py, so what are the in that what are the parameters you are dropping by seeing that Python file where you are doing that?
Yeah. Let me try to open that.
Okay, this is fine.
Yeah, wait. I think Harveen is also joining. So
Okay.
his light electricity has suddenly come back. Just a second. Okay. Yeah. So when we are doing this, so first we load the model. So if you go to the top of the file, Priyanshi. Yes.
Yeah. This is the load model.
Yes. Go to the top of the file, very top. So all these are basically model. So to build these models, you have to import all these things, Wave 2x, CTC, and all these things. So go down. Go down. Yeah, just where you were. Yeah.
Yeah.
So there are a lot of things which we needed to change. Okay. So if you look here, we had to change the convert namespace to omega conf. So omega conf is another concept. So it's a tuple dictionary instead of a dictionary. So we have to do these things. So you see there are so many parameters, CFG model, and then we have to specify we are dropping the one model aspect. We are just keeping one model. So it's difficult to explain here because unless you load the model and look at the architecture and look at what exactly which dictionary key is doing,
Yeah.
It is difficult to explain a little bit, but you
Okay.
see that we are dropping some things here, right? And then if you go down, so when we are loading the model, we are passing the pre-trained model also. So it's loading the parameters from the pre-trained model. You basically have to know in detail. You have to load this model in PyTorch and look at what those dictionary keys actually mean.
Okay.
Yeah.
Okay, so is any other group doing it still, or should I move forward?
Hello, ma'am.
Okay.
May I share my screen? Actually, I have pressed some key and there is some error happened.
Okay.
So,
Yeah, you can share.
actually, ma'am, I was changing that file, but custom model.sh, but I
You can press
want to
E.
get,
Shift
yeah.
E. Shift E.
E. Yeah. So you can change the pre-trained model path, the one that I have sent you in the chat.
So I have to change it only this now.
Yes, yes.
Okay. It's okay, ma'am.
Yes, it's fine.
Anything need to change? Any?
No, you can just save your file.
Ma'am?
Yeah, and now bash and generate custom model.sh. Yeah, it's completed.
Okay.
Okay. Okay, let's move forward then.
Oh, hello, ma'am.
Yes.
Oh, for modifying this generate underscore custom underscore model,
Mm-hmm.
after I modified, I am not able to exit it. It's showing no write since last chance. Add to override. After I
Okay.
enter escape, then
Okay.
shift colon after the WQ, it's not able to
Okay, you can
exit.
share your screen. I'll tell you how you can resolve it. Okay, just try to press escape,
Escape.
WQ, and an exclamation mark.
WQ.
And an exclamation.
Escape.
First
Escape after
escape.
that shift
Escape, then colon.
colon. Colon.
Yeah, I'm not able to see the changes in your screen. Okay. Yeah, I can see it now. WQ, exclamation mark.
Generate underscore custom models E212 cannot offset files for writing.
Okay, just Just press Q and colon. I think you'll have to give the permission.
Q and colon.
Sorry, Q and exclamation mark.
It's not taking.
You need to press escape first. Escape.
Escape.
Colon.
Okay.
Q and exclamation mark.
Q. Oh no, it's okay.
Okay. Now you just need to do. I'll send you the command. You can just type it.
This one, base generate underscore.
Yeah, I'm sending you a command. I think it might not have been edited.
Okay.
You can just paste this command, and then you can edit it again if it is not edited yet. Yeah, now you can open the file again.
Yeah, it's opening.
Yeah, yeah,
Okay,
Nandu.
I see there's a lag.
Yeah. Okay, I see why this problem is there. I have created a repo in my username, so that's why you are facing this issue. Can you come out of the GitHub rep of the Vim file?
Okay.
Just colon Q exclamation mark. Escape colon Q. Yeah, just come out of this. Colon Q exclamation.
Okay, it's coming out.
Yeah.
Hello.
Yeah. Now just type CD and press enter.
Okay. After this,
I'm not able to see updates on your screen.
Oh, it's in group. Okay.
Okay. Now do ls.
Maybe my internet is very slow.
Seems like. Yeah. If you do ls, so this Vakyansh Wave2Vec repository is under my home directory. Okay, so you don't need to clone in your own usernames. That's why you were getting this write error, because you are logged in as my user and you were trying to make changes in your user space. That's why. So there's this Vakyansh Wave2Vec experiment folder here also, right? So you can go inside this one and go to the scripts, inference and all that. And also activate the environment. It is still base, so you have to do conda activate there set, right?
Oh.
Yeah.
Okay. So home.
Yeah, you can save it now. Escape, colon WQ. It will work this time. Yeah. And also activate the environment, conda activate there set.
Okay. Okay.
Yeah. Now you can try to run bash,
Okay.
generate custom model.
Oh, it's completed.
Okay.
Okay.
Great.
Okay. Thank you.
Yeah.
Okay. So let's start with the single file inference. So I have another file here called single file inference.sh. So first let's see what all parameters are needed here. So I need the custom model path, that is my final model.pt path. So I don't need to change anything here. Even the dictionary I don't need to change. I just need to take a wave file path. So let's take some wave file from the IEEE dataset that we already have. So I'll go to my home, Ream, IEEE, sorry, it was IITM, right? IITM, raw, and okay, let's take one utterance from the dev set. I'll just copy this file and I'll again go to my settings. This is /home IITM raw. Then I have the dev set and then I have my file name. So I have specified my file name. My decoder is Viterbi. If I used to integrate it with a language model, I will use KNLM. So first, let's do it with Viterbi rather than doing it with KNLM. So I'll go back and I'll just do bash single file inference.sh. I'll paste the commands in a while. Okay, so you can see over here. Okay, so it's written राज्य की जनता का क्या जनता को भरा समस्या. Okay, I'm not able to read it properly, but yeah, this is the output. If your terminal can show it in a better way, I use Ubuntu, so it's not coming very proper. But if you view it in a proper way, you will be able to view it properly. It's
Slightly increase the font size so that we are able to see that content.
Okay. Yeah. So it's something like राज्य की जनता को भरा समस्याओं करना पड़ता है, something like that. So
समस्या का समाधान करना ऐसा like something.
Yeah, something like that. So I'll paste the commands, what all you need to do. I'll paste the file name as well if you want. It's somehow not getting copied. Let me copy it from here then. Okay, you can paste this path, and in place of user, you can mention your username, whatever it is. Mine was Harveen, so I wrote Harveen over here. And if you want to try it in some other file of your choice, you can go ahead and do that as well. And then just do bash and single file inference.sh. So just try it out. If there are any errors, I'll help you out with that. So this is, we have done it on Viterbi. First, let's do it on Viterbi, and then we can do it on KNLM as well. If some groups are done, you can mention it on the chat. Okay, I'll show my terminal again. This is my terminal. You can see this. I opened my single file and I just did a bash single file inference and I got my output. You just need to change the wave underscore file underscore path. Rest everything will be the same as it is right now. Okay, meanwhile, let's test it on some other file as well.
Hello, ma'am.
Let's make it 2. Yeah, so again, we have some output from another file. कई आदिवासियों समय समय पर, okay, something like that. Yeah.
Ma'am, I'm getting system error.
Okay. Yeah, you can share your screen.
Yeah, sure.
Okay.
Can you check the path of the wave file, Jeevan, once? Is there a wave file that exists at this path?
Okay.
Then you have to go to there is a raw as well.
Yes.
After creating. In your path, raw is not present.
Is there, sir?
No, home Jeevan IATM dev.
Sir, I don't have
Yeah.
DB file, I guess. I guess it is a raw file.
No. Can you press tab after IATM? I want to see what are the folders here.
Yeah, sir, I have done here. It is only processed and raw, sir.
Raw, right? So your dev is in within raw. So raw will come here, right? Inside the path. Raw /dev, then dev, right? So in your path that you are giving in your inference file,
okay,
can you open the inference file? Here raw is not there after IATM.
yes.
Okay, so you got the output.
Okay, thanks.
Yeah.
Hello, sir.
Yes.
Yes.
Oh, actually, I am getting some error.
Okay, please
Yeah.
share your screen.
Okay, can you scroll down and can you open the single file once and after that do an NVIDIA SMI?
I'll do those. Wait one moment.
So this is raw tab. So the path is correct. Let's go back and let's do NVIDIA space -SMI.
Just Q.
Yeah, just colon and Q. Escape colon Q. Yes. Enter.
What meant?
Okay, NVIDIA -SMI. Okay, so the
Okay,
drivers have
can
failed
you
somehow in group 4.
yeah, so can you open the file again? Can you open the file again? Single file inference. Can you do CUDA equal to false? There is a line CUDA equal to true, right?
How it is?
Yes. Yes, this line, CUDA equal to false. Yes, you can save the file. Can you run file now? Bash, yeah. Mm,
Yeah, we need to delete the CUDA argument altogether. False also gives it some.
uh, which instance is it? Group 4, right?
4, yeah.
I'll log in, I'll check NVIDIA's.
Yeah.
So can I stop here? Right.
Yeah, you can stop share, I'll patch the GPU.
Okay.
Group 4, right?
Yeah.
Okay.
Okay, so meanwhile, let's start with the KNLM part. Let's start with the language model. I'll clear my screen. So I'll just do VI and again I'll do single file inference.sh. My file name will be same. My decoder name here now I will, instead of Viterbi, I will say it is KNLM. KNLM. And my language model name will be train underscore text. So let's do it. So now I'll do a bash single file inference.sh. Yeah, so you can see some output has come over here. I'll paste my commands. So it's coder equals to NLM and my LM name will be train underscore text.
Hello.
Hello, yeah.
Yesterday I have completed only Viterbi. LMN language model is yet to done, so it will not work for me now.
Yeah, after your NVIDIA drivers will work, after that you can try to infer on that. So for LM, you will need to go to this folder, cd// the LM folder, and here you will see a file called run lmpipeline.sh. So when you open this file, you just need to specify the name of your LM. So I have put my name as train_text. You can put
Actually, I
any.
started this yesterday, but due to instances close, it is shut down at the middle.
Oh, okay. You can try it again. If you want, you can, if some files would have been formed, you can just delete them. So the files will be present at the main Vacanch experimentation and LM folder. So I have my folder train_txt. You can remove this folder and again you can try with that.
Okay, okay. In LM, I have to delete train_txt.
Yes, but this LM folder will be present in the main Vacanch repository, not
Okay.
under scripts. So under scripts, it's a different LM folder, and in Vacanch experimentation, it is a different LM folder. So you can.
Oh, so here I have to delete train_txt. Na?
Even without deleting, you can just run the command for generating new LM. It will override.
But it will take more time because yesterday it was showing 3 or 4 minutes, but right now it is showing more than an hour.
More than an hour to create a language model?
Yeah, yeah.
That is not possible.
Yeah.
We'll check.
Yesterday, today morning, I tried 2-3 times, but every time it is showing that 50 at first more than 1 hour, then after decreasing it is come to 50 minutes estimated time.
Will
Okay, meanwhile, if the other groups have done, you can just mention your group number.
So group 4 NVIDIA program is fixed. Can you check now?
Okay, sir. So I have to again in script I have to make it true for.
Yeah, you can make CUDA equal to true.
Okay.
Yeah. Can you first try seeing with NVIDIA SMI if you are getting a card now? Because I'm getting.
Hello, sir. Hello. Yeah, ma'am.
Yeah, Ganesh.
Sir.
Yes, sir, it is showing.
Yeah, okay. Yeah, Ganesh.
Sir, it is. I mean, I've tried some 3-4 sets. With the language model, I don't think it is giving somewhat good when compared to Viterbi. Can you comment on it? I mean.
Yes, because the language model text is limited only to the training data. Okay. So generally what we have is to train a good language model, we need to have a big corpus. As I
Okay.
told you yesterday itself. So
Yes.
training is only like 27,000 sentences, right? So it's not that a big corpus. Right?
Yeah. So apart from the corpora, is there any other things that we can infer here?
No, I think only the training set matters actually.
Okay. And in some cases, the Viterbi and Kennelam both are same.
So it can be so if the audio is really very clear and the Viterbi output also got, also got most of the words right. So it is quite possible.
Okay, so the limitation is only the corpora, the
Yes.
LM corpora.
Yes.
Okay, so nothing to infer in this, just.
Yes. So here there are no hyperparameters that you can tune actually. Okay. So the only thing is that what text on your LM is trained on, right? So if it is seen more text, then it will perform more better. So anyways, if you check the entire data set,
Yeah.
it is improving the WER as a whole data set, right?
Yes, as a whole, it is improving.
Yes.
Yeah.
So I mean, similarly, whatever sentences in which you are seeing the result as negative, maybe one or two sentences, but in the other sentences, it might be better than the Viterbi. So that is why the overall WER on the final set is low.
Yes.
Then,
No, I just want to infer like,
yeah.
is it only due to LM biasing or something else?
Yes, it is only due to LM
Okay.
things.
Yeah.
If you have a more general, a bigger, 20 million or 30 million lines, then it
Yes.
is a better chance that your
Yeah.
LM would perform much better.
Yes. Okay. Yes,
Harvey?
sir. Surya sir was saying something.
Oh, no, no. Just this Viterbi and like one more is there, no?
Kennel. Yes, sir.
Viterbi, I think should be always less than or at most equal. It may not bypass the Kellem. Reason is that what somebody knows, he said that exhaustive this one, when you have more database, that is helping language modeling.
Yes.
Yes.
Okay. Thank you.
But actually differences are there. Actually, I have noticed the differences are there. It is doing better. So here is an example. I am pasting in the chat box. So that bana gaye is banaye gaye in the KNA. So some differences are coming with language model.
How much difference is there at word error rate with respect to those two language models?
So with the language model, I think yesterday we checked the WER was 14 on the dev set.
Then
Without a language model, it was 14.
Correct. Then it came back to 8.33 something.
Yes, 8.33 with the language model. Yeah.
Yes.
So we can say relative 6% improvement, sir.
Yes.
60%, not 6.
So no,
with respect to WERs.
Yeah.
Yes.
So even in our statistics, I cannot reveal the entire statistics, but I can tell you that we are getting, WER on Hindi test set in which we are comparing with the Google and Azure. So we are getting a WER of around 21 or 22. But with the use of LM, with the use of a general LM, we have reduced down it to a single digit number.
Okay.
Okay. So
what is the corpora size, sir, which you have used for
as
can
told
you...
yesterday, the raw corpora that we have used was 100 million lines for Hindi.
Okay. Unique lines or like normally crawled?
No, 100 million were the total corpora. Then after processing and all, we removed some duplicates and we did some processing. I think I'm not sure about the exact number, but 30 or 40 million lines were left.
Okay, so 30 or 40 million were unique.
Unique
okay.
lines.
Okay, unique lines were 30 to 40. Okay. For Hindi, right?
For Hindi, yes.
Okay.
So AI for Bharat, I think is an organization that has put corpora in some languages. Okay, so I can check if I have a link. I can pass it on to you. Okay.
Okay.
Hello,
yes, sir.
Harvey.
I have gone through that link, sir. There are multiple 13 cross 13 languages, right?
Yes, I'll pass it on so that other people can also see. So this is the AI for Bharat corpora link in which you can see there are different news articles as compared to different languages. So Hindi, if you check, there are 63 million sentences. Okay, so I think half of them go out when we do the deduplication and all. Okay, so we are using 30 to somewhere around 30 to 35 million.
Okay. And for your inference, have you used statistical or some other model? I mean, LM?
No, we use only KNLM as of now. The other transformer-based LM is still in process, and results are actually not good with the transformer-based LM. and you do not also get a real-time system with a transformer.
Yes, sir. Sure, sure. Yes. Yeah. Okay, sir. Thank you. Thanks a lot.
Yeah. Yeah. Somebody else was asking something.
Yeah, so like your language model is available in open source, right? So if
Yes.
we want to build if you want to put our domain data and build on that, is it possible or?
Yes, yes, of course. So, okay, I'll share my screen. I think yesterday Anil showed you a BioBert model, right? So basically, if you have a biology data, then you can create a domain-specific language model that is compatible only with the. I mean, that is limited only to the biology or chemistry formulas or text. So we have also open sourced that model, domain specific model. In the coming times, we will also open source other domain specific models like financial domain, medical domain, other than commerce domain, or maybe retail domain. Okay. So whatever data we'll get to train LM on, we'll train our LM and we'll open source that as well. But yes, if you want to have a domain specific application,
Yeah, if I have my own set of sentences
yeah.
for some particular another domain, so can I? Is there any way to add it on to your currently existing language model and so on?
Yes, so you can do that. So for that, you have to download the data from here, Hindi data from here. Then you have to perform the deduplication that we did. So after deduplication, we'll get 30 million lines, and then maybe you can add that data to those 30 million lines, and then create a new language model. So actually, in this case, the iterative training is not possible because it's a statistical language model, not a deep learning based language model. Okay, so you have to start from scratch always.
Okay.
Okay. So in the previous language models, in the V1 version, we also gave the data that was used to create the language model. It was 13 million at that time. This was for V1 models, which is now depreciated. Now we are using somewhere around 30 million to 35 million sentences only for Hindi. For other, I do not have the statistics that I remember as of now.
Sir, and one more. All the language model are monolingual, right?
Yes, all the language models are monolingual, and their dictionary has to be the same dictionary as your trained model.
Yeah. Okay.
So if in your training model you do not have numbers, then in your language model text also you cannot have numbers.
Yes, absolutely. Okay.
Any more questions or doubt? Or so, Sajal, is there a LM present in? I mean, the LM with that name present in that folder?
Actually, as Madam told, so I delete that file, text underscore txt.
So no, but okay. So can you share your screen so that we can create a language model again and then we can do the inference?
Yes.
Did you create a new one after that?
So you're saying new LM model was taking like 6 or 7 minutes to create, right? So okay. So can you come down? Can you come down? Okay. So firstly, we'll create a language model. Okay. So can you go one back to the LM folder inside
One
script?
back.
Yeah, one back to LM folder. CDLM.
There is LM.
Yes. Do ls. So vi run pipeline. Can you open this file? Go up. Go up. Okay, so perfect. Just exit from this file. Exit. Yes, and bash run LM pipeline.
Yes.
Run LM pipeline.
Yeah.
Sure.
Yeah. So your language model is created now. Okay. So now you can try the inference. So CD, you can go back to the inference folder.
Sure.
No, if you have to do infer, you have to
Oh,
be inside inference folder, right? Right now you are
okay,
in
okay.
doing folder.
CD.
Dot dot slash. And then inference. Yeah.
Inference. You just press tab, okay, when you write. So
Tab is not working.
because you have written A, so if you delete A, now press tab. Yes. Okay.
Enter.
Enter. And now you can run the infer command if you want to do batch inference that you were running, right? So bash infer. So this is for batch inference, not for single file inference. Okay, so bash infer.
Which one?
Yeah. So now you are running the inference on every trends in the dev set. Okay. So it will take some time to run because
Yeah.
it is running on 3300 utterances.
Yeah. Today morning it is showing lots of time, but right now it's 9 minutes.
Yeah.
Morning it was showing more than an hour. Thank you, sir.
Yeah. Okay. So any more questions in the session? Okay, I think so. See, we have covered a lot of things here. Okay, so we have trained a model. I mean, we have fine-tuned a model on a data set that was provided by IIT Madras, 40 hours data set. Then we had a model, ASR model. Then we created a language model and we integrated a language model on top of an ASR model to get the output. Now your output is in text. Okay, so once your output is in text, then all the elements of NLP come into play. Okay, so now it's no longer speech. Whatever speech component was there, it has already happened. You've already got the text from the speech. Now it is up to your choice what you want to do with the text, whether you want to do some capitalization in the text, whether you want to do some punctuation in the text, whether you want to do some abbreviations kind of thing in the text, like you want to replace doctor with dr dot, right? So you can do all types of post processing on the text that is possible. Okay, so some of the post processing will be covered by Anirudh tomorrow, I think in ITN session, which is inverse text normalization. And Anirudh, anything on that apart from ITN? Okay, Anirudh, you are on mute if you are speaking anything. Okay, so I think in tomorrow's session, Anirudh will cover, like, will tell you how the words can be converted to numbers, because there is a problem with our trained models that the numbers are not coming. Okay, so he might show you a demo in which you convert the words to numbers, And then there might be a demo of capitalization of words, I mean nouns. Okay, so in English output, there will be capitalization of the proper nouns like names like Harbin or Nirud. So if any name comes inside in the text, then it will be auto capitalized. Okay, so these are the things that we'll cover in tomorrow's session. If you have any other questions, then we can take that now, or we can then go ahead for lunch.
Hello, sir.
Yes.
Sir, how to check the word error rate yesterday I was not able to do because of that group 3 was not working.
Uh, so you have to run the inference in batch mode. So I mean inside scripts inference. So there is a file called infer.sh where you have to provide the data set path, and then if you run that file, you'll get the WR and CER. So the steps of that is already mentioned. Maybe you can share your screen. We can tell you quickly what you can do.
Okay. Hello, sir.
Yeah.
So I have to go inside inference.
Yes. So you have to go inside scripts inference.
Inside inference.
Yes. So there will be a file called infer.sh. Right. So in this file,
infer.sn.
sh, yes. So in this file, you might have given the path for the data set on which you want to do inference, right?
Okay.
So you just do bash infer, and your inference would start.
So where I have to
Okay.
give the path?
Okay. Okay. We are now seeing your screen. So did you create? Did you prepare data first for inference yesterday?
Oh, sir, this is Anirudh account user. User is Anirudh.
Okay. Uh, then how do we proceed with this?
We can check if there is something in the data inference folder, else we'll have to prepare.
Okay. I have to check.
Yeah, just press Q.
Just press
Q
Q.
and enter.
Oh, I'm already outside the BI.
Okay, I'm not able to see your screen. I'm not sure. Might be due to an internet problem.
Okay.
Is anybody else able to see?
No, actually, due to lagging in the internet connection.
Okay.
It's not.
Now I'm in inference. I'm already out from BI.
Okay, yeah. So now you can do ls dot slash
LS. Okay.
data inference. I'm not able to see your screen, so you just have to.
I'll stop sharing and we'll share it again.
Okay.
Hello.
Yeah. ls dot slash data
Okay.
fine tuning. Sorry, inference.
Now
I'm still not able to see your screen. If you have gone to that folder, you can just check if there is something in the inference folder.
Okay, okay.
Is there anything?
In the inference, generate underscore custom underscore model dot sh infer
No,
dot
no, no,
sh.
not there. I'll paste a command, and you can just see if there is any output there.
Base.
You can just uh, paste this command and check
Okay.
if there is any folder over there.
Yes. Empty dot text Hindi underscore eval.
Okay, so you do have the eval folder, right?
Yeah,
Okay.
yeah. I have the eval folder
Okay.
Hindi underscore eval.
So now let's do vi infer.sh.
Okay.
And if you can see, there is something like inference data name. So you can mention Hindi underscore eval over there.
Okay, okay.
And then save the file.
Okay. Hindi underscore then
Hindi underscore eval. I
okay.
cannot see your screen, so you have to just go by yourself.
Yeah, I
If
did.
you're done, yeah, you can save it.
Yeah, yeah, I saved it.
Okay, now you can do bash and infer.sh.
Okay.
It should run for you.
Yeah, it's running.
Sorry, I didn't get.
Yeah, it's running.
Okay, okay, great.
I think it's better I stop the presentation.
You can see the outputs, right?
Yeah, yeah, it's running.
Okay, great, great.
So once this command is over, you'll get the WRNCER. Okay.
Okay.
Yeah. Okay, I think if there are no further questions, then we can break for lunch. Jagbandhu?
Hello. Yeah, Arvind.
Yeah, yeah, yeah. Hi.
Yeah, Harbin, you are asking something?
Yes, I was saying, so since there are no further questions, we can then proceed for lunch.
Yeah, so then what time we will resume? So that Rajat will resume or?
Yeah, Rajat will resume with his API, right? So,
Okay, so
yeah.
what time? This is 2:15, 2 or 2:30. What time you want to resume?
I have to check with Rajat, but let's keep it 2:15 as of now.
Okay, Suryakant sir, are you telling something? 2:15 or?
Yeah, yeah, that's fine. That's fine. That's fine.
Okay.
Fine, no? Okay. Okay. So let's hit 2:15.
Okay. Sure, sure. Thank you, everyone.
Thank you.
Bye bye.
Oh, hello, ma'am.
Hello. Yes.
Oh, hello, sir.
Yeah.
Oh, sir, I'm getting 14.23 word error rate.
Yeah, yeah. That is fine.
And sir, how I'll check this graph in what DN? 1DN. Yesterday we went to one website, right, to check
Yes.
the
No,
to
so
visualize.
this is the inference that you are doing. So there is no graph for inference. Okay. So inference is just you have to understand on the data set. Okay. So there is no graph for inference.
Okay.
Yeah.
Hello, Arvind sir.
Yeah.
Yesterday I ran 29 epochs, then I quit.
Okay.
So there was 52% one rate. So
Okay.
then I trained my own model.
Okay.
So right now in language model, it is giving 22% error rate.
Okay. Then it reduced, right?
Yeah, yeah, yeah.
Yeah, yeah. So that is the expected behavior, right? So it will reduce.
Yes,
Okay.
sir. One
If
more
you,
thing.
yeah,
Suppose I am working on a tribal language of Arunachal Pradesh. So it is very much difficult, and I am first time working on speech. So
hmm.
can I use some Hindi models or some of your models? Then I put some fine tuning in data, top up your
Yeah.
model. Then I can use it.
Yeah, absolutely. So even we will also work on a tribal language once we are done with all the 23 Indic languages. Okay. But if you have a tribal data, then what you can do is just use our pre-trained model, and on those pre-trained model, just fine tune based
Okay.
on your data set. I mean, using the same process that we have shown you within the 2 days. Okay.
Yes.
And you will get a model for your tribal language.
So how to get help from if I stuck somewhere, because we need GPU and such kind of things, so it is not available for my institute. So it will be
Uh,
difficult.
See, GPU, even we do not have a GPU, so we pay for the GPU on paper usage basis.
Yeah.
Okay, so we use GPUs on the cloud, so we do not have any physical GPUs with us. Okay, so we are also getting charged.
I know that, sir. Actual
Yeah.
problem is that suppose I am uh, running my model with a expert. So
Hmm.
then suppose you are running a model with
Hmm.
some data, so you know where is the error. But suppose I rented a GPU and
Hmm.
then I am trying with your model, then I start with some silly things, but it can't happen. But if some expert is with me,
Yeah.
then suppose I am giving data and creating some model, then he can guide, okay, here is the
Yes.
problem. So
So
he
see,
can,
yes. So see, things come with practice. Okay.
yeah,
So
yeah,
what I want you, if you can set up this, the same thing that we did on Collab,
yeah.
it's very much possible that you can set up the same thing on Collab as well. Okay.
Okay,
Then at least you can practice certain things.
yes,
Okay, like how the inference work, how the other things, so that you're not doing the, I mean, the small mistakes that you said, right, when you rent a GPU finally for your tribal language or not. But if you're able to get a tribal language data set, okay,
yes.
and I mean, it is of sufficient quantity, like 10, 15 hours or maybe 20 hours or 30 hours or something, then maybe you can get in touch with us, and then we can do a collaboration and train one model with you,
Okay,
right?
okay. That's why I need your contact. That's why I'm telling.
Yes,
So
so no
in
issues with
Twitter, I
that.
can't able to.
Ye- Yes, so see, we are always available on Twitter, LinkedIn, and I don't check mails, so that is why I'm not giving mail, because there are already 1 lakh mails unread in my account. Okay, so I don't read mails. So you can
Okay,
go ahead and check on Twitter, LinkedIn, or you can open an issue in a GitHub repo.
okay,
Okay, you can always open an issue in a GitHub repo, that whatever you want to do, and we will respond you within 2 or 3 days or so. Okay, the response time is not real time. Okay, but we will surely respond you on your query. You can go ahead
okay.
and check, we have responded to all the queries in the issues section.
Actually, Twitter, I want to message you that's for checking, but there shows you have to be premium member and such kind
No,
of
no, no.
thing.
On Twitter there is no premium membership. On Twitter you can message anyone. So first,
Oh,
I think, okay, you give me your account. I'll message you on Twitter. Okay, if you
okay,
have.
okay, 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 sir.
Yeah. So Rajat, that we will be resuming at 2:15. Is it okay with you?
Yeah, I'm fine with that. I mean, if you
Okay.
want to
Okay.
break in
Sure.
between, I
Yes.
thought
So
that.
yeah. So some of the participants have gone for lunch, so they will
Okay,
be back by 2:15.
okay, then I'll join at 2:15 then.
Yes. Yes. Yes.
Okay, thanks. Bye.
Okay. Bye.